Hi everybody, welcome to today's video on ionic compounds and how to figure out the formulas for ionic compounds. So the first thing we want to do is take a quick rundown memory lane right here and look at the periodic table, like in the left hand side here, and remember that atoms in this side of the periodic table have high electronegativities, and atoms in the left hand side of the periodic table, left hand side of the stair step, which goes, actually I guess I missed with the arrows a little bit, it's more over here. These ones tend to have low electronegativities, and that means that they don't want any more electrons. They don't really attract electrons, but the ones on the right side do attract electrons. And because of that, these ones over here, the nonmetals, tend to get a negative charge. -1, -2, -3, and they become anions. So anions are over here, and the ones on the left side tend to become cations, C-A-T-I-O-N-S. And as you might remember, we spell cations with a plus instead of a T, actually, C-A plus I-O-N. And that helps us to remember that cations have a positive charge. If you look at this diagram over here on the right side, you can see there's a sodium atom and a chlorine atom next to one another. Sodium has a low electronegativity because it's found way over, whoops, right there. And chlorine has a high electronegativity. It's found over on this side, over here. Because of that, what will happen in an ionic bonding situation is that sodium will give an electron to chlorine. And so because of that, sodium ends up with a plus charge and chlorine ends up with a minus charge, and they hang out next to one another because opposites attract. So this is ionic bonding, and this contrasts with covalent bonding down here, in which we had shared pairs of electrons forming covalent bonds and making this whole thing into a molecule. Let's take a look at the next page. Alright, so ionic compounds. We're going to make some things that are called binary ionic compounds. And that means that they're made out of two ions. And so let me get a nice pretty color again. There we go. Alright, so what's the formula of a compound made out of these ions? Na gets a +1 charge, Na gets a +1, and Cl gets a -1 charge. And because the number of charges, positive charges and negative charges, is equal, the formula is NaCl. So the number of positive and negative charges are equal in an ionic compound. Let's take a look at another example, K and O. Well, K is just below Na on the periodic table, so K will form a +1 charge just like sodium does. But oxygen is a little bit different. It has 1, 2, 3, 4, 5, 6 electrons in its outer shell, and would like to have, I'll make a little box here, 2 little boxes, showing that it would like to have 2 more electrons. So if potassium gives off 1 electron, oxygen has a -1. But if there's another potassium ion around, or another potassium atom, like one right here, it will give another electron right there. Oxygen ends up having a -2 charge. And I hope you understand that concept, and if you don't, make sure you try and figure that out. Come and ask me or talk to your friends. So K ends up with a +1 and O ends up with a -2. Now how do we get these charges equal? Well, you can only do that by adding more of a certain type of atom or ion in this case. In this case we need 2 of these K's, K pluses. We needed one to give up 1 electron and another one to give up the second electron. So the formula is K2O because we need 2 K's and 1 O. Let's go down to this chart down here and see if we can put together a few of these atoms, or ionic compounds. Let's try Li and F. Li is way over on the left side of the periodic table. It gets a +1 charge. F gets a -1 charge. -1, +1. This is very simple because it's already done. I just wrote down 2 there, didn't I? Sorry. +1, -1. This is the compound's formula, LiF. Last thing we do is we scribble out these charges, or better yet, erase them. And that's the formula. Let's try this, Li and S. Now sulfur gets a -2 charge because it's right underneath oxygen. We talked about that up here. So oxygen and sulfur are very similar. So Li will have a +1 charge, and S will have a -2 charge. Well, we need 2 of these lithium ions to give us a +2. So 2 of them. Each Li has a +1. Sorry, this is kind of messy here, +1. But there's 2 of them. Li with a +1, another Li with a +1, 2 of them, and sulfur with a -2. The charges are equal. So we scribble that out, we scribble this out, and we're done. Let's try another one. How about lithium? Let's try lithium with phosphorus. Li gets a +1 charge because it has 1 valence electron. P gets a -3 because if you look at the periodic table, you'll see that phosphorus has 5 electrons in its outer shell and it wants 3 more, so it gets a -3 charge. So perhaps you can see that, well, you need 3 lithiums to equal out 1 phosphorus. There's another way to do this too. It's maybe seems a little childish, but I think it's fun. And what you can do is you can crisscross these. So we say crisscross applesauce cookies in the middle, just like you did back in 3rd grade. Crisscross, so you take the 3 and put it here. And you take the -1. You just take the 1, not the minus, and you put it right there. So the formula is Li3P if you do the crisscross method. Let's try a couple more here. How about magnesium and fluorine? Mg has 2 electrons in the outer shell, so it gets rid of 2, so it's +2. F has 7 electrons in the outer shell, so it gets a -1. If we crisscross applesauce, we put a 1 here and a 2 there. And the formula is MgF2. Now we don't usually write 1 right here, and then we also scribble out the +2 and the -1. Or better yet, erase them so it looks neat and tidy. But it's MgF2. Let's try this one. Mg with a +2, Mg +2, and S with a -2. Well, hey, this is great because the charges equal out right now. And so 1 Mg matches up perfectly with 1 S. And so the formula is just MgS. Scribble this out, scribble this out. Now if you did the crisscross method here, this is one reason why the crisscross sometimes fails us. You'd put a 2 here and a 2 there. At that point you'd have to recognize that you need to take these to the, I think it's called the least common least common denominator. So 2 is to 2 as 1 is to 1, and we don't write 1s. So the answer to this is just MgS. So scribble everything, all those numbers out. Let's try something really, really tough, shall we? Let's try aluminum with sulfur. Al. It has 3 valence electrons, so it throws away 3 if it's in the presence of something that wants electrons. So sulfur takes a couple of those electrons, -2. But you can see that the charges aren't equal here. So you don't have the same number of pluses as minuses. So you have to think to yourself, how many sets of +3 do I need to equal out how many sets of -2? And if you aim for 6, you'd say, I need 2 sets of +3 and 3 sets of -2. Or you can just crisscross applesauce cookies in the middle and put a 2 there and a 3 there. And then scribble this out, scribble that out, and you're good. Let's move on to the next topic. There are these things called polyatomic ions, and the word polyatomic means many atoms. Polyatomic in ions means it has a plus or minus charge. So here are 3 examples of polyatomic ions. Here's NH4. It's called ammonium. It's the stuff that they put into cleaning agents like Windex and things. Ammonium or ammonia. It's a polyatomic ion because it's made out of 1, 2, 3, 4, 5 atoms. So it's poly, many, atomic, many atoms, and it has a +1 charge. In other words, if you took all the pluses and all the minuses in all of these atoms, you find you have 1 more plus than minus, 1 more proton than electron. This one, NO3 -1, is called nitrate, and it has a charge of -1. And it has 1, 2, 3, 4 atoms. Sulfate, like it's found in sulfuric acid, SO4, 2 negative. So it has 2 more negative charges, 2 more electrons than protons, if you counted all of them up, and it's polyatomic because it has many atoms. Let's see how to, well, I'm sorry, first thing is, I just want to sort of throw this at you for a moment. These are polyatomic ions that we will use a lot this year. And so in the next chapter, the next unit, I'll have you memorizing these, making flashcards and memorizing all of these formulas. And once you get some practice with these, they're really, really kind of amazingly easy. They come really easily to people. So this one's called phosphate, PO4, -3. This one's called acetate, C2H3O2 with a -1 charge. All right, let's see how to use these in making ionic compounds. Now these are called ternary ionic compounds that we're going to make right now because ternary refers to 3 or more. Okay, we're still going to get the same number of positive and negative charges. Let's try this. NH4F. NH4 has a +1. F has a -1, so that's perfect. This is the final formula. This one's a little tougher. NH4S. Now, NH4 has a +1, S has a -2, and that's not equaled out. So we need more of these. More of these. So what we do, we put parentheses around this, put a 2 right here. Like crisscross applesauce, I guess you could say. NH4 +1, 2 of them. S -2, just 1 of them. So this is the formula. Scribble out the +2, scribble out the -2. Let's try another one, Ca and NO3. So Ca gets a +2 charge, and I figured that out by looking at the periodic table. NO3 is a polyatomic ion with a -1 charge. And by the way, you were not, you don't have to memorize these yet. I'll give this to you. I'll just say NO3 is called nitrate. It has a -1 charge, and you just have to be able to work with it. So the thing that you want to remember is NO3 sticks together. So don't break this apart into N's and O's. Just leave it as one thing. So pretend that NO3 is one thing. And oops, Ca has a +2. Well, this isn't balanced out, a +2 and a -1. What are we going to do? We need another one of these, NO3. So I could write 2 right here. But then I would be confused and I would think, is this NO32? That's not what I want. I want to say that there are 2 NO3s, 2 NO3s. And I'll scribble out the +2 and I'll scribble out the -1. And this is the formula, CaNO3 2. Let's do one more and we'll call it good. This, let's put NH4, which is called ammonium if you care, and you don't have to know that just yet, and along with SO4 sulfate with a -2. +1, -2. It doesn't balance out, does it? We need another one of these. So we need 2 of them. And I can't have 42 here, so I need parentheses. And you only use parentheses around polyatomic ions. Let me say it again. You only put parentheses around polyatomic ions. So that's today's lesson. And so let's take a look at what we did. First thing was we had a refresher course on the periodic table and electronegativity. And we talked about the general concept of ionic bonding, where you have positive and negatively charged ions next to one another. We looked at binary ionic compounds in which you have a cation bonding with a certain type of anion. And then after that, we looked at polyatomic ions. We sort of discussed the concept of, this being one entity. It really sticks together. NH4, all those atoms stick together pretty well. You can break them apart with super high heat or something, but usually they stick together. We talked about, our future, where we'll have a chance to memorize these. And then we put together some ternary ionic compounds in which, if we had more than one polyatomic ion, we needed parentheses.